We shall now take a look at a C++ program where we are going to determine if an input matrix is a scalar or a non-scalar matrix. A non-scalar matrix will not define it. Let's define a scalar matrix. A scalar matrix is a square matrix in which all the diagonal elements are the same. So this is a diagonal. So if you see, this is an example of a scalar matrix because it's a square matrix as well as the diagonal elements are the same or equal to each other. So it's quite easy to write a program for this. So A is going to be an array, a two-dimensional array, which is going to store the input numbers 1, 0, 0, 1. I, J are used as indices. I refers to the row numbers, J refers to the column numbers. M and N are referred to how many rows and how many columns the user wants to enter. He may not be interested in a 5 by 5. He may be interested in a 2 into 2 or a 3 into 2, 3 matrice. Scalar, I'll tell you what this does. This also will be clear once we come to that particular part, why these variables are used. So I'm asking the user to enter the order of matrice. M represents the number of rows, N represents the number of columns. Now I'm reading in the rows and columns into a matrice A. So A is going to look something like this, 1, 0, 0, 1. Now what I'm going to do here is, once I have written a matrice, let us go about trying to run through this logic to determine if it is a scalar matrix or not. That is the only way we are going to verify is running this through this logic. So first thing what I'm going to do here is, if the number of rows is equal to number of columns, then only I am processing this. Okay. If scalar happens to be 1, then I am saying it is a scalar matrix. Only if rows is equal to column, then scalar is going to be equal to 1 and it's going to print a scalar matrix. Else it's going to say it's a non-scalar matrix. Alright. So let's come and run through this particular problem. Now what I am doing is, I am first outputting, since number of rows is equal to number of columns, I am saying it's a square matrix. I am making a variable called scalar equal to 1. You will understand why I am making it 1 is because I want to say it's a scalar matrix. So I am using this by making it 1. I am printing it. If scalar is equal to 1, I am saying the matrix is a scalar matrix. If scalar is equal to 0 or not a value of 1, then it's a non-scalar matrix. So let us take a look at the logic here. I have one more variable called as SCA scalar element. This is going to have the value of the 0th row and 0th column. In my case, it is going to be equal to 1. Since is equal to 1, I need to check that every diagonal element must be equal to this scalar element. If every diagonal element is equal to the scalar element, then only such a matrice is a scalar matrix. Otherwise, it's a non-scalar matrice. So I'm doing a loop like this. Okay, the loop is quite simple. I'll explain it. So this for loop is the outer one. This is the inner loop. This if and else is associated with this with this innermost for loop. So this is the if, this is the else. Now, where do I need to check that the diagonal element, or how do I know it's a diagonal element? If the value of I is equal to j, okay, let us start doing it. Initially I is 0, j is 0. Okay, so now that means I am referring to this particular number. If a of ij is 1, because I is 0, j is 0, I am referring to this one. What is the scalar element? It's also 1. Since it's equal to 1, this condition is false. It will not go in here and it will come out of this particular for and go back here. J becomes 1. Now I am referring to 0 and 1. 0 and 1 refers to this particular value here where I am pointing my thing. Is I equal to j? No, 0 is not equal to 1. Then I come to the else part. A of ij, is it not equal to 0? It is equal to 0, so no problem. Suppose it was not 0, then this condition would have changed. Scalar value would have become 0, because for a non-scalar matrix, all the non-diagonals should be 0. So since it is 0, I am not getting into this particular else if also, and I am coming back here. So in the else, I am going to have a if. Now j becomes 2. 2 is not less than 2, so I go back to outer loop. Now I ends up becoming 1. When I ends up becoming 1, I come back here. J is back to 0. 1 0 I am referring to this particular fellow. Is I equal to j? 1 equal to 0 is false. So I am coming to the else condition. Ij 1 0, is it not equal to 0? This condition is false. So it will not go in because it is equal to 0. Now j becomes 1. Now j becomes 1. I is 1, j is 1. So both of them are 1 1. We'll get into this if condition. If ij, this particular element, is equal to 1, absolutely it is equal to 1. So this condition is false. It will not get into here. I'll go here. I'll make j equal to 2. There I come back here. I also increases. I becomes 2. This loop fails and I come out here. Since scalar remains 1, I am going to do a print the result. It is a scalar matrix and I'm going to end the program. One small thing you need to do here is you need to, when you're checking for a scalar matrix, it is good, or in fact it is correct, to make the value of the scalar variable here equal to 1. Okay, because what happens, why I'm doing it, making it 1 outside here is, suppose the number of rows are not equal to the number of columns, it should still, it should say it is a non-scalar matrix, because I'm only checking for a square matrix. So I should make this outside also 1. Rest of the thing, this program is perfectly fine. I'm going to show you a demo of number of all the lab programs, and your concepts will be crystal clear and you'll have the confidence to execute these programs on those machines.